the ones that we're going to be working on today are going to be a little different, and they're going to be a little bit more challenging. All right? Matthew, what can I do? All right, let's take a look at number 6. Number 6 said, I have 5. When I have a number touching a radical symbol, that means 5 times, okay? So 5 times the square root of 320, 320. All right, now remember, our goal is we need to break 320 into 2 factors where one of the factors is a perfect square. So because I need that, it's a good idea to write my perfect squares out. So I have 4. These are my perfect squares. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100, and you could kind of go from there. So these are my perfect squares. This is a list I would start from. All right, it's even. I see that it's 32. I know for sure 32 is divisible by 4. I could start with 4. What other number in this list should you recognize? And if you start with 4, that's fine with me. But what other number in that list do you know 32 is divisible by? Blythe? 16. So either 16 or 4 would work for this. Using 16 will have less work. But you could still use 4. Yes. Absolutely. If you see that 64 is a factor of it, you could use 64. The higher the perfect square factor, the less amount of work you have to do. Okay? I'm going to use, maybe what I'll do is I'll use 4, and then I'll also use 64 so you can see the difference between them. Okay? But yeah, if you figured out that 64 is a factor of 320, for sure use it. All right, so let's do 4. All right, so 5 times the square root. Well, 32 divided by 4 is 8, so this must be 80. So 4 times 80. So you're looking at your steps in this as well. This is the work I'm expecting to see. From here, you are breaking that square root up onto each number individually. So I have 5 times the square root of 4 times the square root of 80. Now I'm going to apply my square root. If you guys didn't have this for 6, you're taking notes on this right now. All right, so now I'm going to apply my perfect squares. There's that 4, square root of 4, that's a perfect square. What is the square root of 4? Sit up, Jacob. What is the square root of 4? Ashton? 2. So I have 5 times 2. Now 80. Does 80 have a perfect square factor? Does 80 have a perfect square factor? Isabel? What is it? 4 for sure, right? And you're like racking your brain, aren't you? Use 4. Just use 4. So 80 is 4 times 20, right? So I'm going to break that up into the square root of 4 times the square root of 20. See, this is going to take a little longer, but you're still going to get the same answer. So I end up with 10, because 5 times 2 is 10, times, well, the square root of 4 is 2. What about 20? Does 20 have a perfect square factor? Ava, does 20 have a perfect square factor? What is it? 10's not a perfect square factor. 4. 4 times what? 4 times 5. So now I'm going to break up 20 into the square root of 4 times the square root of 5. Can you guys see how this works? All right. So now I'm just going to finish up. Well, 10 times 2 is 20. Times, well, the square root of 4 is 2. And then the square root of 5. Does 5 have a perfect square factor? Colin? No. So this is simplified. So I'm just going to throw the square root of 5 at the end. And now I'm going to add these. 20 times 2 is 40 times the square root of 5. Now, if you had recognized that 64, or that 16, if you recognized a bigger perfect square factor, you could have broken it up using that one. Colin, what is 320 divided by 64? So this would be the square root of 5 times 64. So I have 5 times the square root of 5 times 64, and now I'm going to break this up. So I have the square root of 5 times the square root of 64. All right, so I have 5 times, well, the square root of 64 is 8, so I have 5 times 8 times the square root of 5, which gives me the same answer. So you can kind of see, the more you are able to know what your perfect squares are, and if you can use the biggest perfect square factor, if there is one, it makes less work. But you can see that if you use 4, because you can see 4 right away, it'll work. You just got to keep going. All right, give me another one. What else can I do for you guys? Jacob?
I just have a question on tonight's homework. Is it like the same process?
You are going to find out very shortly. All right, what else can I do for you guys? Serena? All right, let's take a look at 8. It's going to have some of the same process, but they're a little different. Okay. If I take a look at 8, 8 says I have the square root of 108 times b to the 4th. All right, so what perfect square do I know is a factor of 108? Ashton? You could do 4 times 27. All right, is there a bigger one? Is 9? Right, isn't that 9 times 12? All right, is there one bigger than that? So I have 4 and I have 9. So another one, Colin? 36 times 3. How many of you guys would think to check 36? Yeah, I wouldn't have. I probably would have done 4 or 9 because I saw them right away. And then I know I can find out more if I need them. All right, so I'm going to use 9. All right, you could use any of those that are perfect square factors. I'm going to use 9. So I have the square root of 9 times 12. All right, what do I change b to the 4th into? Nick? Excellent. B squared times b squared. So now I'm going to break this apart. I have the square root of 9 times the square root of 12 times the square root of b squared times the square root of b squared. Well, the square root of 9 is 3. The square root of b squared is b. The square root of b squared is b. Now I'm looking at that 12. I know for sure 12 has a perfect square factor. It's 4. So I'm going to break that up into the square root of 4 times the square root of 3. So now I'm going to finish this up. I have 3 times, what's b times b? Peter? B squared, excellent. Square root of 4 is 2. Square root of 3 is as simple as it can go, so I'm going to leave that. And now I'm just going to multiply my numbers. 3 times 2 is 6. So I have 6 times the square root of 6 times b squared times the square root of 3. Again, the higher number you use, the higher number perfect square you use, if you can, if there's more than one, the less work. But I really would advise the moment you saw 9, just use it. Because when you get to 12, you're going to know you have to do it again. All right, it might be less time spent overall. All right, put this away, get your notes out. Okay. So today we are focusing on more of these. All right, they're kind of different looking ones. They're a little bit harder. So today is the 22nd. But it's still the same idea, it's still the same process. So I still need you remembering those perfect squares. So let's list them in our notes so you have them in our notes. All right, so today's the 22nd. We are doing chapter 11.1 continued. And we're simplifying radicals. Okay. So let's start by writing our perfect squares. And I'm going to show you how you know it's a perfect square. All right, so my smallest one is 4. 4 is 2 times 2. So I'm just going to kind of write underneath it how we got it. What's our next perfect square up? Jacob? 9. Because 9 is 3 times 3. What's our next perfect square up from there? Nick? 16. Because 16 is 4 times 4. I want you guys to finish this list all the way up until you get to 144. And please have it go in order. Because if you forget them, you can always do what I'm doing to figure them out. All right, so I have all my perfect squares there. Okay. All right, so one of the things that we did, let's review something, because we're going to use this idea. If I wanted to simplify, the square root of 48. I know we did one like this. What perfect square factor does 48 have? What perfect square factor does 48 have? Matthew? What is it? 16 times what? All right, so if we do this, we end up with square root of 16 times 3. What is my next step that I tell you I want you to do? What is the next step I tell you I want you to do? Ashton? Separate them. So this would be the square root of 16 times the square root of 3. I want you to remember this. I'm going to put a star by that because we're going to use this same idea going forward. Somebody finish this for me. What's going to be my final answer? Charlotte? What is the square root of 16? 4. So what's my final answer? Excellent. Do you guys feel a little bit better about simplifying those? Okay? All right, so now what I want to talk about is I want to talk about multiplying two radicals. I want to talk about multiplying two radicals. So we just learned how to simplify a radical. Now I want to learn how to multiply radicals. Again, I want you guys to kind of think back to this step right here. All right? So if I have the square root of 8 times the square root of 12. First of all, I'm going to write some steps over here. First of all, what you want to do first is determine if either radical is a perfect square. Okay, are either one of those a perfect square? You guys are not jumping ahead. You're writing down what I'm writing. Are either one of those a perfect square? Square root of 8 or the square root of 12? Are either one of those a perfect square? Jacob? No. So these are not perfect squares. So I'm going to say neither are perfect squares. Neither one of those are perfect squares. So this is what, and I'm going to put a big fat no here. So if the answer is no, then you're doing this next step. If the answer is yes, then apply the perfect square. And then finish simplifying if necessary. So if this was like the square root of 4, you could do the square root of 4. But then you can also simplify the square root of 12 as well. Right? Okay. If the answer is no, this is what you're going to do. I want you to combine the two radicals into one and multiply. All right, so this is this is what I'm going to do. I'm going to do the square root of 8 times 12. Now I'm going to show this right now like this But as you get better at these, you can go right to multiplying them. What is 8 times 12? What is 8 times 12? Charlotte? So this is the square root of 96. So this is this step here. Now, simplify the radical. Just like we did last night. So Jacob, we are doing the process we did last night, but there's stuff we're doing to get to that point. Does that make sense? Now all of you finish this. Okay, 96. What perfect square factor does 96 have? Serena? How many of you guys use 16 times 6? Awesome. So I'm going to break this up into, now I now am okay with you guys breaking them up individually right away. Are you guys okay with that? Okay, so I'm okay with you doing the square root of 16 times the square root of 6. Does that make sense to you guys? Takes one step out of it, but that's okay. Right? Serena, what is the square root of 16? What's 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 the square root of 16? 4. Excellent. So I have, that's okay, I have 4 times. Does 6 have a perfect square factor? Nope. So this is simply 4 times the square root of 6. Questions on this? Yes.
So, technically, if you wanted to, can't you just use the numbers you started with? Like,
Okay, so you could use these two numbers and simplify them each individually and then end up multiplying everything together.
that's what I did.
Yeah, you could do that if you want. All right, but sometimes that's not, you might not be able to find those, or they may not have perfect square factors, and then you have to do that. How many of you guys understand what Jacob just asked me? Not really? Okay. So I'm going to write a big fat or here. I always hate showing you guys two different ways. All right? I want you thinking of it this way. But what he's saying is, I could technically break 8 into the square root of 4 times the square root of 2, couldn't I? How many of you guys agree with that? Times, what could I break 12 up into? Peter? So I have square root of 4 times the square root of 3, right? And I could simplify it from this way. Can you guys see that? That I then can say the square root of 4 is 2. Here the square root of 4 is 2. Here I have the square root of 2 times the square root of 3. And I can multiply those. I would have 4 times the square root of 6. So either way would work, but I want you practicing this. But yes, I like that you thought that way. Yep. All right, let's do another one. I want you to simplify. Because this way that Jacob did may not work for all of them. This way will work for all of them every time. Can you guys see that? So I want you focusing on this process. Okay. So if I have 3 times the square root of 2b times 4 times the square root of 10b. So this right here is an example of what Jacob was talking about won't work. So now I need to multiply everything together. So I can multiply my 3 and my 4, and then I can multiply my 2 radicals. So I'm just going to move them next to each other so you can see what I did. So I have 3 times 4 times the square root of 2b times the square root of 10b. And now I'm just going to go ahead and multiply. Well, 3 times 4 is 12. I have the square root. What is 2 times 10? And I can do this because it's multiplication. I can't do this as this addition. What is 2 times 10? Nick? 20. What's b times b? Isabel? Excuse me, it's not 2 times b. It's b squared. Now all of you finish this. So I have 12 times. What can I break 20 into? Where one of them is a perfect square factor. Kaylee? Excellent. So I have the square root of 4 times the square root of 5. Well, b squared is already b squared, right? So I don't need to break that further. I just do the square root of b squared. Let's apply our perfect squares. So I have 12 times. Kaylee, what's the square root of 4? Excellent. 5 is not a perfect square. I'm going to leave it alone for now. What's the square root of b squared? b. So I have applied my perfect squares. 5 does not have a perfect square factor, and it's not a perfect square, so we're going to leave that square root of 5 there, and now multiply. I have 24b times the square root of 5. It's a lot of work, isn't it? All right, but just do it one step at a time. All right, I want to switch gears for a second, and I want us to look at expressions evaluating variable expressions. Evaluating radical expressions. So I want to talk about evaluating radical equations. I'm going to say that. Because nobody is going to come up to you on the street and give you one of these. All right, you have to be able to know how to use it. All right, so you guys are in Washington, D.C. All right. This is a picture of the Washington Monument. I'm going to read this to you, okay? It says, the formula, and I'll tell you what the formula is, can be used to estimate the distance to the horizon from the height of the viewer's eyes. So you're standing somewhere. You might be standing on the top of some building, all right? It's the height of the viewer's eyes above the ground. You can estimate how far you are away from this. Okay, so I can estimate how far away from wherever I am to the Washington Monument if I know the Washington Monument is 500 feet. All right, so let's figure out what I'm talking about. All right, so this is example number 4 from page 279. So let's write down the information that we said. You can use the formula D equals the square root of 1.5h to estimate the distance d, so that variable d is distance, to estimate the distance d in miles to the horizon. So you're looking at something on the horizon when h is the height of the viewer's eyes above the ground. All right, so what I want you to do, I want you to estimate the distance a viewer, the distance a visitor to the Washington Monument is, hang on a second, I'll move this right. It says, estimate the distance a visitor at the Washington Monument can see to the horizon from the observation window. So estimate the distance a visitor to the Washington Monument can see to the horizon. All right, we know that the Washington Monument is 500 feet tall. All right, so here is my H. So that 500 feet is my H. So distance equals, what does that mean to evaluate this equation? If I know that 500 is my height, what does it mean to evaluate the equation to find the distance? Come on, you guys. Come on. I know the distance formula. This is my distance formula. I know the height of the Washington Monument. They've given me that height. How am I going to figure out how far a person is from the horizon if I know the formula for the distance to the horizon and the height of the figure that they're looking at? Come on, you guys. I'm not telling you. We're going to be in here till you figure it out. Talk to someone sitting by you. This is a no-brainer. All of you should know how to evaluate equations and evaluate formulas when you're given variables. What am I going to do to evaluate this formula for the information that they've given me? I have two people raising their hands. All of you should be able to answer this. This is a basic understanding of algebra. What am I going to do to evaluate this equation in this situation? Ashton? So what am I putting in? Yes. Substitute that 500 in for the H. That's a no-brainer. All of you should know that. All right. If I multiply 1.5 times 500, I get 750. So D is equal to the square root of 750. And from there, you need to figure out this. You need to go through what we just did. So what perfect square factor does 750 have? We know 1 for sure. Just by looking at it, we know 1 for sure. Nope, 25 for sure. All right, so if I use my calculator, 750 divided by 25 gives me 30. Right? Yeah. So this is going to end up being the square root of 25 times the square root of 30. All right, so this ends up being 5 times the square root. Well, does 30 have a perfect square factor? I don't think so, does it? So this is simply D is equal to this 5 times the square root of 30 miles. Now, this is exact. For us to estimate, just put the square root of 750 in your calculator. So for us to estimate, we're just going to do the square root of 750 equals 27.386, and I'm hoping they give us a direction. If we round to the nearest tenth, this is approximately 27.4 miles. So throwing it in the calculator and actually finding the square root of it is an estimate, and exact is the answer with the radical in it. Are you guys cool with that? You guys can go.